Example 2. Exactly 152 yellow peas using table A2. Using the same information from the previous example, find the probability of exactly 152 yellow peas among the 580 offspring peas. That is, given n, which is a sample size, is equal to 580, and assuming that probability of success is equal to 0.25, find the probability of exactly 152 yellow peas. Is this result useful for determining whether 152 yellow peas is significantly high? So the first thing we want to do is, like we did in the previous example, was to find the mean and the standard deviation. Well, the mean is equal to n times p. We know that n is 580. We know that p is 0.25. Multiplying that together gives us a mean of 145. Standard deviation is equal to the square root of n times p times q. Well, we know that n is 550. We know that p is 0.25. Q is taking 1 and subtracting 0.25, which gives us 0.75. We multiply that together and take the square root. We get the standard deviation of 10.4283. Now what we want to do is we want to draw and label the normal distribution with a mean of 145. We have the standard deviation of 10.4283. And then we're going to shade the area that approximates the probability of exactly 152 yellow peas. That is, the region is the vertical strip between 151.5 and 152.5. So let's go ahead and draw that. So over here, we're going to draw our bell curve. Okay, so let's draw our bell curve, and then we're going to label the mean. So we know the mean is 145. Okay, and so we look at the value of exactly 152. So if we take a look at the value of 152, let's go ahead and draw that. So here is the value of 152. Okay, and so what we want to do is we want to find out, using the continuity correction, to represent the discrete value of 152 in the graph of the normal distribution. Well, remember that if you take x and subtract 0.5, and we take x and plus 0.5, then 152 minus 0.5 is 151.5, and 152 plus 0.5 is equal to 152.5. So now what we're going to do is we're going to label those two. So let's say that this represents the value of 151.5, since that is below. And then over here, this is going to represent 152.5. Now, just make it a little bit larger here for the area, just so that we can see what's happening. So what we're looking for is, since we're looking for the approximation, we're looking for the area that's in between these two values. Okay, and the reason is the following. Okay, if we take a look, this shaded area, okay, is the approximation that approximates the probability of exactly 152 yellow peas. So therefore, we're going to say that this area here represents that approximation of exactly 152, and that approximation means we need to then look at the left, which is 151.5, and into the right of 152.5, and 152 lies within there. So the next thing that we want to do is we want to be able to then convert this into a z-score. So we're going to look at the z-scale. So in order to find the area that's in between these two, we want to find out what is the z-score for 151.5, and then what is the z-score for 152.5. So we're going to convert 151 and 152 to z-scores. So if we take a look at the first one, z1, we're going to use 151.5. If we take 151.5 and subtract 145 and divide it by the standard deviation of 10.4283, we get 0.623303, and rounding that to 2 decimal places gives us 0.62. And then we want to find the other z-score that's associated with 152.5. So therefore, we're going to use now x to be 152.5, subtract 145 and divide it by 10.4283. That gives us 0.719196, which then gives us 0.72. So now we found our z-scores. So what we want to do is we want to use the table to find the area for 0.72 to the left of that and to the left of 0.62. Well, if we take a look at 0.62, this is 0.62, okay, and then we also have the area that's to the left of 0.72. So there are our two areas. Let's go ahead and circle those. So to the left of 0.62 is 0.7324, and then to the left of 0.7 is 0.7642. So again, using that table, we convert our two scores to be 0.62 and 0.72, which yielded cumulative left areas of 0.7324 and 0.7642. So what we want to do is, if we take a look at the region to the left of 0.72 and the region to the left of 0.62, we want to subtract the area to the left of 0.62. Okay, and so what we can do is, we know that that area, which is in this case 0.7324, so that's going to represent this area here. We want to subtract that from the area to the left of 0.72. And then that'll give us the area that we want to find. So if we take 0.7642 and subtract 0.7324, it's going to give us 0.0318. Therefore, the probability of exactly 152 yellow peas is going to be 0.0318. Now let's take a look at the interpretation. Now, in an earlier section, we saw that X successes among N trials is significantly high if the probability of X or more successes is unlikely with a probability of 0.05 or less. In determining whether Mendel's result of 152 yellow peas contradicts his theory that 25% of the offspring should be yellow peas, we should consider the probability of 152 or more yellow peas, not the probability of exactly 152 peas. The result of 0.0318 is not the relevant probability. The relevant probability is 0.2676 found in the first example. So in general, the relevant result is the probability of getting a result at least as extreme as the one obtained.